Hi, students and friends. This is your host and teacher, Sayyid Ayazuddin Haider, and you're watching Learn and Teach by Sir Ayaz. So, I will continue my video session for O-level past papers. Last time, I was doing paper 41 of 5070, and this time I have selected 42 for 5070, and it's of May-June 2023. I'm not going to read the instructions and the information as you already are aware about it. So let's start the paper. Here's question number 1. Student investigates the rusting of iron. Figure 1.1 shows the apparatus the student uses. Here's figure 1.1. You see in experiment A, we have apparatus X in which there's iron nail. It's placed in water. In experiment B, there's iron nail placed in a test tube with dry air. Dry air means no water, and they have placed stopper on the top of the test tube. In experiment C, there's iron nail. It's placed in water, and there's a layer of oil on the top of the water. A. Name apparatus X. It's test tube or boiling tube. B. State why a stopper is used in experiment B. It's simply to prevent the entry of water. Experiment B, you can see the stopper, and there's a dry air inside the test tube. Dry air means no moisture, no water. So it means they're preventing the entry of water. C. State why the water in experiment C is boiled before use. The boiled water does not contain oxygen. It removes oxygen. Oxygen is more soluble in cold water. So you'll write remove oxygen. In fact, dissolve oxygen because oxygen is more soluble in cold water. D. State why a layer of oil is used in experiment C. You can see in experiment C, there's a layer of oil. It's a layer of oil. So why they are using it? To prevent the entry of oxygen. Part E. The experiments are left for 1 week. Predict in which of the experiments the nail will have rusted. Explain your prediction. You can see these 3 experiments. In experiment A, there's no stopper on the top of the test tube, and iron nail is also placed in water. So both oxygen and water, they are present. So definitely in experiment A, the iron nail will rust. What about in experiment B and C? In experiment B, there's a dry air and stopper on the top of the test tube, which prevents the entry of water as well as oxygen. C, there's a layer of oil on the top of boiled water. This is boiled water. They have boiled it. So it also does not contain oxygen and water. So it will not rust in experiment C. So answer will be experiment A. Only the nail in experiment A will rust. Will rust only. So explain your prediction. Both water and oxygen is present. is present, or you can even write or needed. Moving to next question. Question number 2. Aqueous ammonia is a solution of ammonia gas. A student titrates 2 samples of aqueous ammonia A and B with 0.5 mole per dm cube hydrochloric acid. The student does 4 titrations, 2 with A and 2 with B. The student, step 1, rinses and fills a burette with 0.5 mole per dm cube hydrochloric acid. Step 2, uses a volumetric pipette to add 25 centimeter cube of A to a conical flask. Step 3, adds 5 drops of methyl orange indicator to the conical flask. Step 4, places the conical flask on a white tile. Step 5, adds 0.5 mole per dm cube hydrochloric acid from the burette while swirling the contents of the flask, adding drop by drop near the end point until the solution just changes color. Swirling means mixing. Step 6, empties the conical flask and rinses it with distilled water. Step 7, repeats step 2 to 6. Step 8, repeats steps 2 to 7 using aqueous ammonia B instead of aqueous ammonia A. Figure 2.1 shows the burette readings for the 2 titrations with A. This is titration 1 and titration 2. So there are initial and final readings for both of these titrations. Record the burette readings in table 2.1. Complete table 2.1 with the volume used in each titration. So final burette reading for titration 1. So if you can see, it's 15.12. So 15.2 will be the final reading for titration 1. What about the initial reading? It's 0. So I will write 0 here. Volume used will be 15.2, as 15.2 minus 0 gives 15.2. What about titration 2? 30.12. So you write 30.2 here. Initial reading 15.12. 15.2. So I will write 15.2 here. So the volume used will be 30.2 minus 15.2 gives 15 centimeter cube. B. Figure 2.2 shows the burette readings for one of the titrations with B. Is titration 4, and then we have initial and final reading. Record the burette readings for titration 4 in table 2.2. Complete table 2.2 with the volume used in each titration. So for titration 3, final burette reading is 34.9 and initial burette reading is 0.2. 34.9 minus 0.2 gives 34.7. So this will be the volume used for sample B. What about titration 4? The reading is there. If you look at the reading, 35.12345, 35.5. What about the initial reading? 0.12345.6. So it must be 35.5 and 0.6. So if you subtract 0.6 from 35.5, what you will get? 35.5 minus 0.6. You will get 34.9. C. Explain why the student uses a white tile in these titrations. As I have mentioned in the steps, they are using white tiles so that student can easily observe the color change. to observe the color change more accurately. D. Calculate the mean volume of 0.5 mole per dm cube hydrochloric acid needed to neutralize 25 centimeter cube of A and of B. So I'm going to write the volumes for the acid needed for solution A on the left hand side. We have 15.2 and 15. 15.2 plus 15 and divided by 2 in order to get the mean value. So what you will get? You will get 15.1 for solution A. What about solution B? We have 34.7 plus 34.9 divided by 2. 34.7 plus 34.9 divided by 2. 34.8 will be the mean volume for solution B. Moving to next part. E. The equation for the reaction between hydrochloric acid and aqueous ammonia is shown. HCl plus NH3 gives NH4Cl. Use the mean volume of acid needed to neutralize 25 centimeter cube of A in D to calculate the concentration of ammonia in A. Give your answer to an appropriate number of significant figures. Now we have the number of reacting moles. For example, if the number of reacting moles for HCl is N1 and it is 1 here, so I will take N2 as number of reacting moles for NH3. Apply this formula. We have M1 V1 by N1 is equal to M2 V2 by N2. So we need to find the concentration of ammonia. So it means M2 must be the concentration of ammonia. So I will write M2 here. So in order to calculate the M2, the equation becomes M2 is equal to M1 V1 by N1 multiply by N2 by V2. Both N1 and N2 are equal to 1. Sorry, here we have 1 moles of ammonia, not 2 moles. 1 mole of ammonia. So they will be cancelled out. So we are left with M2 is equal to M1 V1 by V2. M1 is the concentration of hydrochloric acid and V1 is the volume of hydrochloric acid needed to neutralize solution A. So M1, where is M1? .5 mole per dm cube hydrochloric acid. This is M1. So I will write 0.5 multiply by volume needed to neutralize. The volume will be 15.1. 15.1. And the volume of ammonia used is 25. So what you will get? 0.5 multiply by 15.1 divided by 25. So the concentration is 0.302. 0.302 moles per dm cube of ammonia. Calculate the part F, calculate the volume of ammonia gas measured at room temperature and pressure RTP dissolved in 25 centimeter cube of A. The volume of 1 mole of any gas at RTP is 24 dm cube. So the moles for the solution A is in 1 dm cube. 1 dm cube means 1000 centimeter cube. So I will write 1000 centimeter cube contains 0.302 moles. Therefore, 25 centimeter cube contains X moles. So X is equal to 0.302 multiplied by 25 divided by 1000. 0.302 multiplied by 25 divided by 1000. It's 0.00755 moles. Now, in order to calculate the volume at RTP, you need to multiply these moles by 24. Volume of ammonia gives 0.00755 multiplied by 24. 0.00755 multiplied by 24. What you will get? You will get 0.18. 0.1812 dm cube. Or you can even write 0.18 or 0.18 dm cube. G. Use your answers to D and F to calculate the volume of ammonia gas measured at RTP dissolved in 25 centimeter cube of B. So we'll use the same formula in order to calculate the moles per dm cube. Here, so we'll have volume of B (34.8) is the volume of B. So M1 V1 is equal to M2 V2, and we are calculating what? We are calculating previously M2. M2 is the concentration for ammonia. So M2 becomes equal to M1 V1 by V2. So M1 V1, it remains same. 0.5 is the concentration. And what about the volume? Volume is, this is the volume for HCl, not B. 34.8. The volume of ammonia is 25. So we will get 0.5 multiplied by 34.8 and divided by 25. So we'll get 0.696. 0.696. These are in thousands. Mole per dm cube. So you'll write 1000 centimeter cube contains 0.696. Therefore, 25 centimeter cube contains X. So 0.69696 multiplied by 25 divided by 1000, and then it will be multiplied by the 24 in order to get the volume of ammonia B, 0.4176, or you can even round it off to 0.418. So this will be the answer. H. The student rinses the burette with 0.5 mole per dm cube hydrochloric acid immediately before it is filled. Explain why the student should not rinse the burette with distilled water immediately before it is filled with 0.5 mole per dm cube hydrochloric acid. So you can write any one from these. Definitely, if the student has washed with distilled water, some of the water will remain in the beaker, and in this way, hydrochloric acid becomes diluted, then more volume will be needed for the titration. So you write any two from some water would remain in the beaker. HCl becomes diluted. More or greater volume of HCl needed for titration. Number one, suggests why universal indicator is not suitable for use in these titrations. Student cannot observe the color change clearly. The color change cannot be seen clearly. Question number 3. A student investigates solution W and solid X. A. Solution W is green in color and contains Fe2 plus ions. Number 1. Describe how W can be shown to contain Fe2 plus ion. You look at the qualitative analysis. Note, you'll see Fe2 plus ion, where it is. It is here, Fe2 plus ion. The test is with either with sodium hydroxide or with aqueous ammonia. And see the test, we'll get the green PPT, which is insoluble in excess. So you can either write add sodium hydroxide or aqueous ammonia. The result is same for both of these. So you can write green PPT insoluble in excess. Green PPT insoluble in excess. Number 2, excess W is added to acidified aqueous potassium magnate 7. Describe the color change seen. So aqueous potassium magnate 7 is oxidizing agent. It will definitely oxidizes Fe2 plus to Fe3 plus. Fe2 plus is green in color and Fe3 plus is brown in color. So where we have aqueous potassium magnate 7 is there. So this both of these color will be combined and gives this yellow color. So you write green to yellow. Number 3, describe the observations made when a few drops of aqueous ammonia and then an excess of aqueous ammonia are added to the mixture from 2. Now this time you are testing the presence of Fe plus 3. So what will happen? For Fe3 plus, you will see red-brown PPT, either with sodium hydroxide or with aqueous ammonia. In both the cases, and it's insoluble in excess. So you write red-brown precipitate and insoluble. Moving to next part B. Solid X is a shiny gray metal. The test the student does on X are shown in table 3.1. Some of the observations for these tests are also shown. Here's table 3.1. We have the test on solid X and observations. Number 1, add excess dilute acid to X in a test tube. The gas produced is tested. Observations: solid disappears, solution remains colorless and becomes warmer. Test 2. Add dilute nitric acid, then add aqueous silver nitrate to some of the solution from test 1. Observations will be solution remains colorless. Number 3. Add dilute nitric acid, then add aqueous barium nitrate to some of the solution from test 1. In observation, we'll see white precipitate. Number 1. Predict the identity of the gas produced in test 1. So it's a reaction between metal and acid, and you will always get hydrogen gas during this reaction. So you'll write hydrogen. Now they are asking about the test and the observation to confirm the gas. So we'll see the test and observation for the gas from here. Where's the gas? Here's the gas, hydrogen gas H2, pops with a lighted splint. So you'll write test lighted splint and observation will be pops or pop sound. Number 2, the observations for test 1 are incomplete. State one other observation that the student makes for test 1. Test 1 is the reaction between metal and acid. This is the reaction between metal and acid. So hydrogen is produced, as I've already mentioned. So you definitely observe fizzing or bubbling. Bubbling or fizzing. You can even write effervescence. These indicate the formation of gas. Number 3, state the conclusion you can make from test 2. What is the test 2? Here's the test 2. Add dilute nitric acid, then add aqueous silver nitrate to some of the solution from test 1. Solution remains colorless. No, silver nitrate test. This test is performed in order to test the presence of the halide ions. So we have halide ions here. All these tests, silver nitrate. So we don't see any change in color. So you'll write halide ions absent. There are no halide ions. Halide ions absent. Number 4, state the conclusion you can make from test 3. What conclusion you are making from test 3? This test 3, dilute nitric acid and adding aqueous barium nitrate turning to white precipitate. So here's barium nitrate and we are getting white precipitate. It's presence of sulfate or SO4 minus 2 ion. SO4 minus 2 or sulfate ions are present. Number 5, identify the acid used in the test 1. It must be sulfuric acid. At sulfate ions are there. This is a reaction between metal and acid. So you write sulfuric acid or H2SO4. Number 6, suggest the identity of metal X. Coming back to the observation, you see solid disappearing and solution also becoming warmer. So it's not very fast reaction. So it can be either magnesium or zinc because both of these are among the moderately reactive metals. Number 4, baking soda is used to make bread rise. When baking soda is heated, it decomposes and carbon dioxide gas is released. Baking soda also decomposes gradually when it is stored. The longer the baking soda is stored, the less carbon dioxide it releases when it is heated. Plan an investigation to show which of 2 different samples of baking soda has been stored for longer. Your plan should include the use of common laboratory apparatus and the 2 samples of baking soda. No other chemicals should be used. Your plan should include the apparatus needed, the method used, the measurements to take, the variables to control, how to use the results to determine which sample has been stored for longer. You may draw a diagram to help you answer the question. So for the apparatus, I will talk in the end. So let's see the marks for this question. Total mark for this question is 6, which means you have to add 6 points, or you can add 4 points and 2 diagrams. At least one diagram or apparatus must be there. So let's divide it. We have 1 here. We'll do this later on. And we have method and measurement. So we'll place it number 2. And we have a control, number 3. And using the result, so we'll see what we have deduced in the end. So let's start from number 2. For number 2, they are talking about method and measurement. So any one of these you can write. So method and measurement, so you have to measure the mass. You have to measure mass, then you have to heat it. Then you will measure the volume of gas or bubbles produced. Then you will measure the time in which the gas is turning lime water milky. So we will start measure the mass. Measure the mass, heat the samples. Then measure the volume of gases produced. Volumes of gas produced. Or measure the time to turn lime water milky. Now, what about the variables to control? What do you have to control? Number 3. So you can have any one of these. So you must have same mass. You have to start with the same mass. You must have to calculate the change in mass or the volume produced. When you are heating, you have to heat it for the same time, for same length of time, or same to constant temperature, or heat the constant mass. So we'll write same mass. Calculate change in mass or volume heat for same length of time. Or heat to the same temperature, constant temperature, same or constant temperature. Constant temperature means you have to provide the constant heat for both of these samples. Okay, how you use these results? Number 4, any one of these. So how using this result, that sample that produces more gas will take less time to turn lime water milky. Sample that produces more gas or more bubbles, or loses more mass. In this case, loses more mass, will take less time to turn lime water milky. Now, opposite true statement will be true for the sample that produces less bubbles or loses less mass, will take more time to turn lime water milky. So milky, if it's milkier, which means stored for less time. Stored for less time if lime water is milkier. If it's stored for a long time, it will turn less milkier in this case. Now, number one, they said that you can draw any of these apparatus. They are asking what apparatus you can use. So you can draw anyone from these, any one of these. Like you have balance. If you want, you can draw the balance. This is balance. You have reading. What else you can draw? You can draw the Bunsen burner. Bunsen burner will be like this. Or you can draw the test tube. Or you can draw the flask. Or you can draw the equipment to measure the volume of gas produced. We call it gas syringe. So for the other two marks, you can draw any one of these apparatus and any one of these statements which I've mentioned here. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.